ordered set of fields. A field is just like a piece of data or information. Okay, this is the basic jargon. Okay, like used in the pig script, especially in the pig. Even in the logs, when you observe that one, people also would be calling as a bags, tuple, fields. Okay, this is the jargon that it's been used. Okay, and it's not hard. Okay, like whenever you try to use it uh, for a couple of scripts, then you will get to use it very easily. Uh, when I try to execute an example, maybe at the time I will show you. I'll show you. Okay, like what is a bag, what is a tuple, what is a field, all the details. Are you able to audible now? Hello, am I audible now? Are you able to hear me? I'm not sure. I'm using the same way. Okay, good. I'm also switching the video. Statement in the pig scripts corresponds to a relation. A relation is nothing but a bag. A bag is a collection of tuples. A tuple is an ordered set of fields. A field is a uh, uh, piece of information. Okay. In other words, a field is called like a column, and a tuple is called being a row. Okay. A relation or a bag will be called as a table or relation in a typical SQL world. Okay, like but here each relation need not be derived from a table or anything like that. A subset of data also will be called as a bag. Okay, so that's a counterparts of the pig or jargon. Okay, like which is used in the pig side. Next one, okay, like referencing relations. Uh, in a pig script, each statement corresponds to a relation, and every relation in a pig script has a name or alias. So this is very important, and once we know about this, um, uh, uh, it's very easy, okay, like to understand or even to code or to write pig scripts. So each statement or each relation in pig script has their own name or alias. Uh, and these names will be assigned by the coders or developer like who are writing the pig script, and this naming the relation will be a part of pig latin statement itself. Okay, um, so here maybe on the screen you are seeing that there is a uh, pig statement, okay, like which is started from the letter a equal to load sample.txt using pig storage of comma delimiter as name, carrier, age, int, salary, float, like that. So this is a sample pig statement. Okay, like and in the last task itself, we already gone through that. What is the typical layout of a pig script? Pig script always starts with the load statement, and it has some set of transformations statements, and then end either it have a store or a dump. Okay, so this is the typical layout of pig script. So here, the highlighted line, okay, like is one of the load statement. Each statement in a pig script has a name or alias, right? So here, A is the name of the statement. For the entire the statement, okay, like so it has its name. So A is, I mean, just like sample, okay, like so I just name it as a capital A here. So A equal to, okay, like load. So that means we are loading the data. So from where we are loading the data, okay, the file name called like sample.txt, okay, and then using and pig storage, Pig storage is a storage method in the pig which will be used, okay, like read or store, to read or store, to read or save the files in text format. So this is the default, what do you call, default API storage type that pig would be using. So pig storage, whenever you use the pig storage, that means it will be used for the reading of the text files. Okay. And pig storage has an argument. Okay, like here, argument is a comma. So that indicates the sample.txt file has all the fields separated by the comma. If you don't give any of the argument for pig storage, defaultly it will assume that all the fields are separated by the tab character. So to override the default behavior, so you could also pass the single character, whatever may be the delimiter of the fields in a sample file, you could pass it to the pig storage. So here, for example, like here I passed as a comma there. And as after as, okay, like you could see that there is a bunch of schema statements here, name and its type, char array. Char array is nothing but it's a character array of characters which is a equivalent to the string. Old versions of the pig does not have the string; they do have char array only. But the newer versions has string as well, so we could use alternatively either of them. Okay. And age is just like an integer, so age colon int or integer. You could do int or even integer as well as a full word. And the next one is a salary, which is of a float. Remember, each statement in a pig has its own name or alias. So here, A is the name of the statement. A equal to load. So every statement in pig will be like this syntax only. Some name equal to your statement. Every statement will have its alias. Um, since alphabetics are very easy, so people would start with A, B, C, D, E, like that. But typically in the industry, okay, like they will try to name some meaningful word. Okay, here I'm loading the sample data text file. So instead of A, I would say like it's a sample data, like that. Okay, like so this aliases need not be a single numeric characters or single alphabetic characters. Okay, like it has a word as well. So I could say like sample underscore data equal to like that. All this pick statement. Okay, like you need to make sure that like the name should be unique. If you can also give the same name, and if you give the same name, it will be overwritten by the existing definition or the existing value. Okay. And next one, and the next statement, okay, this is the entire thing about a pick sample statement. Okay. We'll also see like different ways how to run load statements as well. And the next one is dump A. Dump is the statement which will dumps the value of your value of the variable that you've been passed to. Okay, like dump A. So whenever you see the dump A, the pig what it does is it will try to get the definition of A and it will run that statement and the results will be displayed to the screen. Okay, so here you could see this one exactly like so. I mean, this is one of the sample. Okay, like I will try to show you the output as well. Okay, like but here I do have the name as John. John age is 42 and it has the salary as 65,000. Mary 34, 45 6,000. Jonathan 27, 50,390 something. Bill has 32, 78,600 like this. Okay, like and here if you observe that the each statement in peak corresponds to a relation or a bag, right? So here A is nothing but a bag. So the result of A or whatever the A corresponds to a bag. Okay, like so. Here the entire this result will corresponds to a bag. So everything results will be called as a it's just like a bag of data, okay, like a bag. And here, the each row or each line of these results corresponds to a tuple. So the John 4265,000 is called a tuple here. So this bag has five tuples, okay, and each tuple has three fields. First field is called like name, second field is called age, third field is called salary. So that is what like here we have given. Okay. So what I will do is let me show you exactly okay like how to run this statement and what is our input file here. Then you would realize. I'm just starting the cluster. Just bear with me a couple of minutes. Sure, I will try to increase the font size. I mean, this is what I used in the last class. Okay, like so. Um, Probably are you able to see that in the item? Okay, like don't worry about this virtual box. Okay, like anyway, we're not going to read anything from the virtual box, but this is main important. Okay, like so. Are you able to read this one? Are you able to read this highlighted one? Again to Vijayanagar. Maybe this is the only maximum that I'm able to see. That. Quickly, I will try to create a file also. Okay, like then yeah, it doesn't take much time. So every statement in pig, okay, whether it has something like A equal to or B equal to or C equal to D equal to like that, or else even it has the words like sample data equal to okay like that. I will also show you some of the scripts uh, that I have written for some of the projects. Okay, like in the trailers. So each statement should have an alias or name. Okay, so I have a sample file. Okay, like this. I will also show you. It has name, age, and their salary. Name, age, salary. Okay. So this is what the input file that we got. So we would like to see that read the file from the page and then you do some transformations in the page. So that's what our goal is. So for this one, what I could do is okay, like let me go with only the local mode because we are not doing any HDFS files or anything on the cluster. So the beauty of the pig is okay, like we don't require to have Hadoop cluster or to run on the Hadoop or like that. So you just install the pig and any of them, and then you could use pig minus X local. So most of the time, developers they use the pig local mode, and whenever they feel comfortable, and then they return the script and everything, then they try to execute it okay, like in the cluster mode or in the map adjustment. So here I'm going to read the same way, like whatever the slides that I have shown you. Load sample.txt file. Since I use the local mode, I could use the local path. Okay, like that means Unix local path. And if I run pig minus x page or pig minus xmr or just pig, that means all the file pointers are pointing to HDFS, not the local one. So if you use the pig minus x local, then only you could use the local path. Okay. Load sample text using pig storage. And here I'm specifying that what is the delimiter of my fields. So all the fields in my file have been separated by comma. So that's the reason I'm seeing the pig storage of comma. Okay. Frankly speaking, this would be enough for us. Okay, like so we need not give using pig storage as name and everything. They are all like um, what do you call it's just like specifying the schema while reading. But without that also we could run that one. So let's try this. Okay. So A equal to load sample.txt using pig storage. So this is my pig statement. So each statement should have a name. So here the name is just like A. Okay, like so what I could do is dump A. So dump what it does is it will get the value or it will just display the bag onto the screen. That's what the dump were. That's what the dump does. Okay. So here, after all the log statements, here you could see that. And remember, what high level, what does this pig does? Pig converts your pig Latin statements into a Java MapReduce. Okay. So instead of writing your MapReduce programs in Java, okay, like the pig allow you to write into a pig Latin statement, and then these statements will be converted into a Java MapReduce program. That is the purpose of the pig. Why the people has really invented pig or why they've been using? because it's writing a Java map, it is very tedious, and also that required the Java skills, like take longer time and you to compile, to make the job, the sequence of the jobs, and put dependency on one to on the another one job to another job, and then run them in sequence. So it's all like very time consuming and very tedious ones. So that's all the things done by the team. Okay. Good. So these are the all the five tuples. Okay, like so this bag has written five tuples. Okay, like so, and when inside the grunt shell, okay, like you could use the arrow marks. Okay, like to go back to the previous statement. Use up arrow. Okay, to go back to the previous statement, and then use the down arrow. Okay, like to go to the next statement afterwards. Like that. That is a. So this is my first statement, and this is my second statement. Okay, done here. And let's try to change little bit things on the first statement, and also maybe I will change these names. Don't I mean most of the people, most of the tutorials, okay, like they explained about A, B, C, D like that only, and that's why most of the people will write in the same manner. They always start with some A and then B and then C like that. But it need not be. Okay, like so you could just put something like that. Okay, like so here sample data equal to load your sample data text using big storage. And while loading, you could also specify the schema. So here there are multiple ways how to specify your schema. Let's, for example, name, second one is age, and then salary, right? I could just specify their names. Okay, like this is also a very valid statement in the page. So while specifying the schema, you could just specify that what are the names of that one. So defaultly, Pig assumes all the fields are of type string or char array. So if you don't specify any of the data type, it will be assumed it as a string, or it will assume that it is just like a char array. And then you could say dump sample data. And this will also will give you the same results like last time. The last statements which have been printed, okay, like so, they are the that is the result. And before that, all the things are. You could also read from all the statements, okay, like, and then you could understand what is going on and everything. Um, I will explain that whenever we get some good time. I don't want to waste all our valuable time on this logging thing. Okay, but this is the data that is being displayed. So here, this is also one way. Okay, like we could also define like that. And another one, okay, like so another way, just like name, age, and salary. So I mean anyway, just we are learning about this one, so let's see that. Okay, like so um, only name, okay, equal to, so there is a statement called for each sample data, okay, like generate name. So here what we're telling Pig is that sample data is my alias or my name of my name to the relation, okay, like uploading statement. And for all the tuples in the sample data, okay, like just get the only the name. I don't want to read anything else. Okay. And for this, for each sample data, generate name. For this, for each statement, I need to put some alias anyway. So for this one, I just put only the name. And now I could say like dump only name. And here, what I'm expecting is that it should give me just only the names like John, Mary, Jonathan, Bill, Joe, like that. Let's see that. So here in this script, okay, like I do have three statements. Sample data is the first one. I'm loading the file and then using the pick storage, and then I'm getting a name, age, salary, and only name. Okay, like and then from that tag, I'm grabbing only the name. Okay, like and then I'm dumping that. Here another one is it byte array or char array? I think it's char array. The default thing is char array. I'm pretty sure I think it's char array. Yeah. Default it will assume that everything is of string type. Okay, like so. Vijayagaram, they are asking about default type is byte array or char array. I think it's char array. Okay. Dump only the name. Okay, like so it does. So you could extract some of the fields or which we are interested on. Okay. And the next one, let's try to get something else here. Okay, like so. Let's change from sample data. Sample data with type. And here, for each field, I'm specifying that their data type. So name is of character char array, and age is of type integer, and salary is of type float. So I got all the results. So this is how you specify the data type while loading the data itself. But sometimes you may not have or you may not be knowing about what is the data type of the data as well. So for that one, it's safer. So you just leave the data type and default it will assume that it is char array and it will read as a string. Because most of the data types, okay, like you could be read them as strings. Okay, that's one. Um, so this is about the first statement or first page in our thing. Clear everyone until this? Okay. Next one, okay, like I will also show you this. Um, Pig will also allow you, okay, like uh, to refer the fields by their position. Okay, like so. One way to access the fields is using their names. So here you could define like name, age, and salary. So we could use their names, okay, to specify that columns, okay, to specify that column value. And the next alternatively, okay, like you could also use their position. So they always the field positions start from zero. So here $0, of course, whenever you are fixing the positions, the positional value will always be prefixed with the dollar. So $0 corresponds to the first position or first field. $1 corresponds to the second field. And the fields will always be positioned from left to right. Okay, so here name is $0, $1 is age, $2 is salary. Sometimes what would happen is you would be reading about having 500 or 1000 fields from a file. Probably you may not be interested to have all the fields or all the fields. So you are interested or maybe one or two or three. So you know that what are the positions of these fields. So you could simply specify that using their position like $3. I'm interested only with $3 like that. Okay. So here let's try that. I'll also show you um, sample data with type. Okay, like and the next one is I need names with salary. Okay. So for each sample data with type, okay, like generate, I'll use both. Okay, like so name and then $3. So the name we know that our name could also specify the name, or you could also specify the $0. Both are same. $0 and $2. The $0 represents the name, $1 represents age, and $2 represents salary. Okay, $0 and $2. And we could say down names as salaries. So I got a name and then corresponding salary. Name, salary. So this is another way of like accessing the fields using their positional parameter. And their positions are, yeah, I think they will call it position notation. Like so $0, $2, $3, like that. So if you have like 1,000 fields, so if you are interested only in the 600, you need to specify all the 1,000 names of the column. Even it's not required at all. Okay, like so here even sample data with type, I specified the names, but I can leave all the things like this. Maybe try to give something else here. Just sample data, that's fine. So my sample data equal to load sample data using quick storage. That would be enough. I need not specify the column names and I need not specify the data types as well. And then next one is names with salaries. For each sample data, generate $0 and $2 and then dump. That's it. This one will give you exactly. So even though you have 1,000 or maybe more than 1,000 fields, I did not specify their names. Even I did not know about their data types. But whereas I'm interested only in a couple of fields. So if I know that their position, okay, like uh, using the whatever the delimiter that they have been separated by, I could use the position parameters and then I can get into that one very easily, like this. And you could also change the order. So first one is $2 and next one is age and then next one is $0. You could also do like that. And yep, try this one. You could play around. So here I got the salary first and then name because $2, $1. The only thing that you need to remember is that the first field is always starts with zero, $0. It's like array index. Okay, like the first element of array is always start with a zero index, right? The similar thing. Okay, clear everyone? How we could access the fields using their positional parameter? Positional parameter has a lot of advantage. Okay, like when you're accessing about a lot of fields, like 1,000, 2,000, like that, and trust me, even to list down all the names of the fields of 1,000, this is very time consuming, right? It is hectic and time consuming. So to avoid all that thing, okay, like the peak, they started using this, they introduced this position notation. So you need that without specifying all the 1,000 columns, okay, like what are the columns that you are interested on, okay, like so if you know that what is their position, okay, you can just get them very easily. That is the advantage. Okay. So here each relation in a big split, okay, like we already talked about, is a bag, right? A bag is nothing but a collection of tuples. And each bag may have or can have duplicate tuples. So your tuples pig will not verify that whether the tuple exists in the bag or not. So typically a bag can have the same tuple multiple times. And the second one, a bag can have tuples with a different number of fields as well. So the number of fields available in the tuples is also not fixed. I mean, the pig will not force you to have the same number of fields for each tuple. in a bank. So some people may have 4 fields, some people may have 6, some people may have 8, like that. It's still a valid scenario. Okay, like, and then uh, Pig handles that case. So whenever there is a missing field or if the field does not exist for some of the tuple, so Pig injects just null value for that. It just displays a null value. Even if you see here, even in our example, if I try $3, because $3 is not available in the file itself. Okay, like so if I tried this, it will just simply give me the null value, nothing else there. Okay, because $3 is not existing, right? So you get like empty. And technically, a bag can have tuples and a tuple will have the fields with different data types. So some tuple may have one data type and other tuple may have different data types as well. Technically, even that scenario also it would handle that. Okay, like it will uh, forcibly, okay, like it will try to convert from one type to another type. Okay, like that kind of a scenario. But very rarely, okay, like I'm not seeing much of the cases where some people have one data type and some people will have different data type like that. Okay, like but technically it supports. But if you want to process these bags effectively, okay, like so, make sure that all the fields and the tuples that you have been handling will have the same data type. Okay, like so that that is the one that we need to make sure that. Okay. For example, if half of the tuples include the carrier fields and while other of include the float and only half of the fields will participate in any other kind completion because the carrier fields will be connected as well. So, and if you try to compute like average or any mathematical operation on this field, okay, like so, if any fields are not having the same data type, okay, like that will be considered as a null, okay, like for your computation method, whether sum, min, max, okay, like for this kind of a function that you use it. So for other data type fields, it will be considered as a nulls. So that is very, very important thing. So Pig supports two types of bags. One is called like a inner bag, another one is called like an outer bag. Okay. A outer bag is nothing but a relation. Okay, like when I say relation is a bag, okay, like that will be considered as outer bag. Um, I will also show you what is the inner bag as well in the next example. Then you would realize very easily. Okay, I think here. Okay. Um, Next, importantly, okay, like what are the different operators are available in the page? One is the dump. We already saw that dump operator or dump areas. Whenever you give a dump one, okay, it always displays the results on the screen. Okay. Next one, you could also use describe. Okay, like so here. So whenever you try to run the describe, so here names with salaries of type byte array. Okay, like of course byte array or char array are the same. Okay, maybe probably that could be the confusion with the region around. Both are same. Okay, like at least from the usage the data type perspective. So here names with salaries. Okay, like because we are generating only one column, which is of $3. Okay, like so I will show you something here. Uh, sample data with type. And here you could see this one. What is the description of this alias? Will give you back. Okay, so you could get the description or the definition. Okay, like what is the data type and its corresponding name. So sample data with type has three fields: name, age, salary. Okay, and anything in this flower braces. Okay, it's called like um, represents a bag. Okay, like it, and the bag. Okay, these are the fields. These are the data type. That's what the describe will be. Another one. Okay, like another operator. Okay, like which is very helpful for debugging purposes. Will give you logical, physical, and also the MapReduce execution plans of any relation or band. So it will give you, it will tell you exactly this is the logical plan, this is the physical, and this is the MapReduce plan and everything. So for that, explain is the operator. All the keywords are case sensitive, so you could use either way. Okay. So this one we run with explain. Okay. Whenever you run with the explain, it will give you what is the logical plan. Okay, like I'm not going to go to a deeper dive on this. Really, uh, it would be helpful for the debugging purposes, but not for the even regular one. So you could see that one. What is the whether it's been converting from one cache to another, one type of data type to another data type, and something like that. What is the load schema? What is the internal parameters and everything will come. What is the logical plan? What is the physical plan on that? And what is the map at this plan? The logical, physical, map at this plan. So all the three plans will be there. It will simply see that one how many fields are there. Okay, like and for each, how many for each field, what are the data types? Are there any conversions are being there or not? Okay, like so how the values are being uh, converting into, and then like from where it is being loading out. So for each statement in Penny, you could run explain, you could run describe, and also there is other one which is called like illustrate. This one will take one of the example and then it will show you. It will explain you with one tuple and how it's happening and all that stuff like this. So it will take to the first row of the sample data and it will give you name means John, age means 42, salary is this one like that. This will also be very, very useful. Okay, like whenever you are debugging or testing your fixed statements and like that. Like so, loading is pretty straightforward. No one would try to debug there, but at least after transformations, after having some couple of transformations, you want to see that exactly what is going on, what is happening, and how this um, uh, conversion or transformation or changing from one value to another value is happening in the peak value execution. So these statements are very, very useful. Describe will give you the data types and their names, and the explain will give you logical, physical, MapReduce plan. Okay, like uh, for your statement, for your transformation. And illustrate will explain, you will take one row from the input source and it will give the sample output for that row. So that it will be very, very helpful for understanding and debugging purposes. So these are the very four diagnostic operators. And dump is also like for the debugging purpose only. No one wants to display your end results on the screen, right? Okay, like so the dump is also one of the um, helpful feature for debugging purposes. And the next one, I have a bag data, okay, like a bunch of rows, okay, like with three columns like field 1, field 2, and field 3. Okay, like let me try to create this time. Okay. So I got this one exactly like so here. Um, this this relation, okay, like on the A statement, it will be considered as the outer band. Okay, like so because the entire result is only one bag, and there is no, in other words, there is no inner bag inside the bag. So if there is a bag inside a bag, if the inner bag, the inside of the bag is called like inner bag, and the outer one is called like an outer bag. We will also see that in which scenario that we could see that in the inner bag. Suppose, okay, like for this, and this is my statement, right? And V equal to, okay, like what we could do is, we will try to group the first element here, okay? We'll try to group all the tuples based on the first element. So the how many tuples we do have starting, or we do have the same field one. So there are no other tuple with the field name, field value, or F1 value as 1, and F1 value as a 4. There is one tuple, there is a, this is the second tuple, and this is the third tuple. There are three rows or three tuples. Um, for the field 1 value as 4. For the field 1 value as 8, there are no rows. And there is for field 1 value as 6, there are two tuples. So this is the one, and this is the other one. So what we'll do is B equals to, okay, like I will try to simply group A by F1. So we are trying to group all the tuples, okay, like based on field 1. So now you could also, so I will try to just show you, describe B. Then now you would see that. Okay, like so B has one is group, of course the group value is integer, and then A, and the entire A, okay, like is in flower braces again. So anything in this flower braces, as we already defined, that is called like a bag, right? So the entire B is a bag, and out and inside the B there is another bag, and this is called like an inner bag. Okay. Of course, you could also like dump and see the values. Maybe it can be much more clear. We'll see that. Okay. So this is my result now. So the B has returned four tuples for me. Okay. and one is my field one, and then this entire thing is called like a bag. So, for example, the four, I do have bag of four tuples. For the field six, I have bag of two tuples, and eight, I have one tuple. So this is what. And here, this is called like inner bag. This is also called inner bag. This is also called inner bag. This inner bag has how many tuples? Four tuples. Like that. So each entire this result is called like a bag, and it is nothing but the outer bag. Okay, like this has four tuples, and this one is called like inner bag. Of course, you could have not only one inner bag, you can have multiple inner bags like that. D is the relation of bag of tuples. The tuples in relation D have two fields. Okay, the first field is of type integer. The second type of the second field type is bag. Okay, like that's what when you describe here, describe B. So this is the one. So first field of type integer. The second field of type really a bag. And of course that bag is has tuples of type relation A. That's what it indicates, that describe. You could also use illustrate, okay, like illustrate or explain. Okay, this is a very nice. So here it will now here it took the example of six really and has three five. There are two tuples which has the value of f1 as six. And then for the when you entire bag of two tuples, first tuple has 636, this is one tuple, and 695 is one tuple. Tuple, each tuple is separated by this. Okay. Normal base. Okay, like and the bag has flower bases. Okay. So whenever if it is not clear, you could use the describe name, and even the describe is not giving you the enough information, you could say, okay, like, a lot of times. Okay, it always helps. Wait, then it will give you with one row as an example. Okay, with still one row, one sample, give the value inside that. It's all very self-explanatory. Shall we go to the next one? Okay. Next, importantly, they Pig also has Pig supports map types. Okay, like a map, of course, whether it can be a Java map or uh, high map type or even in the Pig. Okay, there is the same thing. Set of key value pairs is called like a map. Okay, like wherever it is, it's the same definition. And Pig is not an exception here. Pig is also same thing. And key values within the relation, okay, like must be unique. Okay, in a given relation or in a given bag. So all the keys of, will be unique, and values need not be unique values. Values can have duplicate values, but keys cannot have the duplicate values. Okay. Um, Very easily. Okay, like so. Uh, here address has been defined as a map type. So how to define a map type in the peak? Okay, like here you could see that load map data text using peak storage as ID. It has the ID of integer and then name as a char array and address as defined as the map. Okay, like so that means this map has set of key value pairs. Okay, like so here the key value, here the keys are address has street and state. I think here I have shown you only two of them. Um, name, yeah, street name and state. Okay, like there are two keys which have been defined in the address. So while b equal to for each a generate ID, okay, like here the name and address of street. So how to access a particular value of a key belongs to the map? So you need to use this hash symbol. Okay, like address, anyway, we know that there is map, hash, then key. Key, just remember, you always keep as a constant kind of a stuff. So put it in single quotes, then only it would work. It should be a string or numeric, okay, like even integer also it should be fine. But whenever it is a alphanumeric or string, you need to pass it as a single quote. So street as street, address, hash, state as state, and then you could say like dump b, it will give you a value like this. And even the inside the value also like a key value separator is hash only. Okay, like and then each field is separated by the comma. So key and value are separated by the hash. So I thought like it's not a major important or heavily used inside the pig. I am not used anywhere. It's very rarely used, but I would like to highlight that. Okay, like yes, pig also supports map. Okay. It is not there in the older versions of the pig. Okay, like I think pig 12 or 13 onwards they introduced the map. Shell and utility commands. Inside the grunt shell, okay, like grunt shell will also allows you to use file system commands. Very, very handy. Okay, like sometimes when you're running the pig script, you may end up in using get the file from HDFS or get merge the file from HDFS. Okay, like or maybe you may end up put file some into HDFS, or maybe you might end up to see the count from in a HDFS. Okay, like this kind of any kind of a scenarios. Okay, like so. Bottom line is use FS and then run your commands inside the pig script. So it allows that. You could, if you put like sh and then some sh and then it will also allow you to queue your shell system commands like any shell system from big script. Let's try to see that. Okay. Try to use fs and then you can give okay like hyphen ls. I think that should be enough, I guess. Let's see. Okay. Now this one has given a local one. Oh no. Yes. Because I used pig -x local. Okay. That's right. Let's quit from the grand shell and use the pig. If I use the pig, it always goes to the HDFS. Okay. And then FS LS. In the file system, especially about the ls command, if you don't specify any of the path, then it's always give you user level folder. okay, like our user level directory structure, user level directory contents. So here FSLS, if it I'm not given anything, so this is all user level directory contents. Or else, in other words, this should be same as slash user slash hdfs. Okay, so the content should be the same. Um, Not only this one, so you could also specify any of them, okay, like a get or put or any other command like count. All these ones would work. So you have a count, how many files and directories under that user HDFS words directory in HDFS. Okay, so you could run some file system commands using the grunt shell using the fs prefix. And the next one, using the shell commands, you could also use this also, I think, would work. If you use the sh and ls, then there is a shell command. So anything on the local file system, you could also run that one. Remember, I am in grunt shell. Okay, like inside the grunt shell. So that's about both fs and sh. And the next one, some of the utility commands are there. Okay, like so it's clear the screen of Big Grand Shell. Earlier, this command is not at all there. I think the 13, Pig 13 onwards, okay, like the introduce this clear the screen concept. Earlier versions it does not have that. And the next one is execute run a pig script. So inside the grunt shell, you want to run any of the external pig script. So you could also do that. So like run some pig script. Any pig script, okay, like dot pig, and then semicolon, like that. Okay, execute is one command. If you want to run the pig script inside any of the pig script, okay, and help, it will give you all the pig commands and properties. Okay, like so run the help, it will give you. It will give you whatever the possible combinations that you could do with the pig command with just like help. And history, so history will give you what are the commands that we run in the grunt shell. So this is the same thing even if you use like upper arrow and lower arrow, or somehow it's not coming up. It should give you exactly. It shows the command series so far. I'm not sure. Okay, like I will find out and I will let you know. And here's a given job. Okay, like whenever you run a pig script, obviously it will run a Java MapReduce program. Okay, like and then it will submit the job to a cluster, and then you do have a corresponding job ID or application ID. And pig is much more of a handy. So you could just like whenever you don't want to run that job, so you could just like hello and then you pass that ID as application ID or something like that. Whatever the application ID, okay, like so you just grab that one and then kill that one. It's directly kills that job. Okay, like outside of PixScript also you could do that. An application ID, application ID, and then kill. Okay, like that will kill the job. Okay, it is much more handy inside the gun shell itself. You could do that and quit from the pig gun shell. Okay, like I think I already showed you like how to quit that one. Run a pig script, execute and run. I think run, if you use the run statement, it will remember the aliases and everything. And if you execute the pig script, it will not remember the alias for the next one. Okay. And set shows and assigns values to keys used in the pig script. So to set some of the configuration value or like that, like set mapreduce.q.username equal to something else. Okay, like you could use it with set. Like this. Whatever your variable names and everything, like set mapreduce dot q dot name. This is one thing that people would use it and use it. Oh, sorry, there won't be any equal. Set mapreduce.map.off equal to 5, and similarly in this also you need to give the space. Okay, that's good. Like that. That's about the set. Okay. Um, yeah. Starting level in the next class. So let me see that if I miss any of them. These are my old one. Okay, yeah. Expressions. Okay, like so any of the mathematical expressions. Okay, you could also use in the P. Like if you want to multiply with field 2 by field 3, you could also do that one. Okay, like and then you could use concatenation of field 1 to the field 2 like that. Okay, if you want to combine the values of multiple fields together, okay, you could also do that one. And filter operations, like filter is used for the um, filtering out the data. Okay, like just like a where conditions. Okay, like filter A by F1 equal to 8 or F2 plus F3 is greater than F1 like that. So you could also pass different conditions like this one. It's like this. Filter A. So filter will be used like if you want to eliminate some of the tuples based on these conditions. Okay, like you could do that. Or if you want to include some of the tuples based on that one also like you could include that one. Filter A by F1 equal to 8 or not F2 plus F3 is greater than equal to F1. Um, we already saw this. You can just this is my question. Okay. Similar to the dump will always be defined the results of the screen, and whereas the other one is called like store. The store will write your results to a file uh, on the file system. So, but the store requires a path. You need to give us first store A into like that, or store sample data into, and then you need to give a path exactly wherever that we want. Like if it is a HDFS, you can just give the HDFS path, or else if it is a local path, you use the local path. And then the result of this, whatever the final bad result, that will be written onto the file. Okay, so that is the difference between dump and store. Dump will always display the results into the screen. Store will always display the results into some file or file system. That's the only way. The name or aliases of relation are always case sensitive. Remember, all your names that you're defining in the fixed script, okay, they're always case sensitive. We cannot use like upper A versus smaller A like that. So both are different. We'll treat it as both are different. But whereas the big keywords are all case sensitive, like load, group, okay, like using, okay, like all the statements are okay, like case insensitive, like dump, generate, okay, like all these things are insensitive. So you could use either uppercase or lowercase. But typically, all the keywords people would use as a uppercase only, so that like at least um, we know that that is a keyword. Okay, that's not the user-defined variable or anything like that. Like it's just like keyword. To identify that kind of a things, people would use it. Like, follow that everything, all the keywords in the uppercase. So that's one. I will explain you in the next class what is the difference between store versus dump, and also, and then we can go from there to the evaluate functions, and I will explain about some more storage functions like that. I'm sorry, I need to leave a little bit early today, as I told you. It's already 10:30 your time, right? So I will leave here. Okay, like until next class. We'll see some of the evaluate functions, what are the functions that are again available. If possible, we'll try to go one by one by one. Okay, like, and then I'll explain about store the system, and then we'll see that some more things on the page. Okay, like, and then I will try to run some couple of statements. Okay, any questions so far? Sorry for leaving you early today.
Thank you, Professor, for